overview of conics and then dive into circles. So conics come from these, it comes from this like two upside down cones, two cones, one that's upside down and one that's not, but that are attached there at the vertex. And conics come from slicing that figure in different ways. So we can get a circle, a parabola, an ellipse, or hyperbolas, depending on how we slice them. And we're going to be talking about each of those. So 11.1 is all about the circles. We just need to review some tools that we need to be able to do some work with circles. One is, how can we find the length of a segment? Well, we can find it by using Pythagorean theorem. So Pythagorean theorem, remember, is a squared plus b squared equals c squared. So in this case, we didn't know this yet, but you can count the length, the rise and the run, the 3 and the 4, plug that into Pythagorean theorem and simplify it. So that's one way when the numbers are small and it's easy to plot them on an x and y graph so you can actually see that. Another way to find the length of a segment is to use the distance formula. So this is our distance formula, and you guys should have seen this last year. But I just labeled the first point here x2, y2, and the next one I labeled it x1, y1. It doesn't matter which point we call which, and the formula for some reason just starts with x2, so I just labeled my first point as my x2s. Plug them in. Simplify. -5 and -7 is -12. Square that, it's +144. -3 and -2 is -5. Square that, it's 25. Combine those, it's 169. Take the square root, it's 13. Remember, we only need the positive version because we're talking length. Okay, the next thing that we might need is the midpoint formula. So it's basically you're just adding your two x coordinates together and your two y coordinates together, and then you divide it by 2. So here's our 2 points, -5 and -4. Plug them in, and we will get the point +1, -1 when we simplify that. Now let's dive into talking about a circle. Well, by definition, a circle is the set of points that are the given distance, a fixed given distance from the center. And that distance here is what we call the radius. The center we call HK, and any point on the circle would be represented by a point XY. And we have the standard form of the equation of a circle. And it all comes from finding this distance. So if we take that distance formula and change the D to an R, because we're talking about this length here, and then we're going to change the x1 and y1 to h and k to represent the center. Kind of get rid of the square root by squaring both sides, and we come up with the standard form of a circle, which is that right there, which is also in our definition down here below for the standard form of a circle. So that tells us some things, right? It tells us what the center is. The center is at HK, and it tells us what the radius is. Let's look at a couple problems here real quick and see what our work might look like. What is the standard form of the equation of the circle with a radius of 3 and a center of 0? So that means HK is 0, R is 3. it's really just taking things and plugging them in. So we're going to go, I'm kind of just writing the template of it. This is what always stays the same. And then we can go through and plug in what we were given in the problem. So h and k are both 0, and my radius is 3. So that's the equation. Now let's just clean it up a bit. X minus 0 is just x, so that would be x squared plus y squared equals 9. And then the next one, let's say HK, or our center, is negative 1, 3. Our radius is 2. So let's go ahead and put that template back up. That's Y. So here our h is negative 1. So when we put in a negative 1 with a subtraction sign, it's going to change it to positive. I'm going to put a 3 in here, and here it's a 2. So we don't want to multiply these binomials out. In standard form, they're left like this, so we can actually kind of see where the center is. So that's x plus 1 squared plus y minus 3 squared equals 4. Okay, now let's look at this from a little different perspective. Now we're given the center, and we're given a point on the line. We don't have the radius. So the first thing we have to do is find that radius. So we have some choices. We can use Pythagorean theorem, or we can use the distance formula. I think I'm going to use Pythagorean theorem because it's right here. It's already on a graph. And I can count 3 and 4, rise over run. Oh, we already did that one. That's the example we did with Pythagorean theorem. So if you look back, you can find that your radius is 5. Okay. So now we're just going to take the center that's at 2, 4, and this radius to write the equation of the circle. Why don't you go ahead and do that? Okay, once you plug it in, there is what you should be getting. So example 8 here kind of takes things backwards, and it gives us the equation and wants us to find the center and the radius. Well, the radius is going to be 3, because 3 squared would be 9. So if we look at the point here, the formula says minus h squared. So we have a positive 2 there, so what must have been in there for h is a negative 2. Because that's what a negative 2 would have changed that to positive. And then our formula is y minus k. Well, it's a positive 1 there, so that means we would have had a positive 1 over there. Then we have this general form of the equation of a circle, and this is where things get a little tricky. It's kind of like using completing the square. But what's happened is they've taken that standard form, the x minus h squared plus y minus k squared equals r squared. And they've multiplied all this out, okay? And remember, these are just numbers. So when we simplify all that out, and all of our number portions are added together to be c, this is what we get for the general form of the equation of a circle. Now, looking at it, it doesn't show us anything. what we have to do is we have to take that general form and we have to put it back into standard form to be able to pull out the key pieces. So something like this one, I have x squared minus 4x. I'm going to group the x's together, group the y's together, and then plus y squared minus 6y equals, I'm going to move the constant to the other side because that's where my radius is going to be. And basically what we're going to do here is in each of these groups, we're going to complete the square. So to complete the square, you're going to take that middle term, divide it by 2 and square it. So that's going to be, what, -2, -2 squared is +4. So if we do it to one side, we have to do it to the other. Now, what we did was we just made a perfect square, x minus 2 squared. Now we have to do the same thing over to the y's. So -6 divided by 2 squared is going to be 9. Add 9 to both sides. So that's y minus 3 squared. Simplify things here, and we get 9, which I'm just going to write 9 as 3 squared, knowing that I have to write it as the radius squared. Okay. So once we've done that, now we know what the center is. The center is at the point 2, 3, and the radius is 3. That's it for the notes.